Hi folks, see you speaking again. Today we're going to have a couple of reminders and I'm focusing on how to make a electronic switch, let's call it a toggle switch, using one of these two typical packages, 7476 for the TTL, respectively the 4027 for the CMOS. And I hope at the end of it we're going to be able to distinguish between the two. Let's just start it. Come here closer. Here in the top, I put a label on it. This is the 7476. And in the bottom is the 4027. Now, I have two push buttons. And when I'm going to press one of them, let's say I'm going to press the red, just focus on the push button. You see the LED above it? It shows that we have a momentary switch. The LED changes, it goes off. Only when I hold the button, when I release it, it goes back to where it was. Exactly like a push button. At the same time, if you take a look on the effect, this is going to enter on the clock input of the flip-flop, and the package has two flip-flops inside. I have here one output, I have here the second output. The red push button and the red LED, they trigger the first output, and I put also a red LED just to prevent confusion. Okay? So, as you can see, the light here went off and back on, but this one remains on. Take a look when I press it now. This one goes back red, but this one goes off, because here is a switch. It goes on, it goes off, it goes on, it goes off. Similarly, for the second switch, because again the package has two JK flip-flops inside, I'm going to use the green. And if you only focus on the green, as long as I press the green, is a momentary push button, you see? But in the moment you are going to watch the output remains on, and then it goes off, on and off, on and off, which means the little flip-flop inside, of course, it's a memory circuit. It memorizes the previous state. So in the moment you gave it the command to go on, it remains on. It gives you the next command to go off, it goes off. Why the two LEDs here for the two clocks of the package, they remain on, while the LEDs for the second package, they are off? Simply because, as if you take a look here on the screen, the clock pulse input, CP, stands for clock pulse. The clock pulse input for the 7476 has a bubble here, meaning the signal is expecting to stay up, and when you actuate it, it goes down. So this is why the LEDs are on, and when you press the push button, they go off, because it needs a falling edge. While for the second package, which is the 4027, this one here, if you take a look at the clock input, like this one, we're going to discuss it soon, the pin 13, there is no bubble on it. This is why that LED and respectively the push button actuating it is off. However, when I actuate it, take a look what happens. The effect over the output is going to be the same. You press it, it goes up, the LED here goes up, and the toggle goes on, off, on, off. Similarly, the green, it does the same thing. You see here is only as long as I hold the button on, I release it, it goes back. I press it, I release it, goes back, but this one stays, because this is a switch, is a toggle, okay? So we can get the same effect when I press the red, this one stays on. When I press the red, this one stays on. I press the green, the other one also stays on. And I press the green, the other one stays on. So why do I insist on that, on the toggle switches made with these two packages? Because if you look on the internet, you're going to have a lot of confusion how to use properly these packages to build toggle switches. And here is exactly the point, because you want to get that result. Now I'm going to show you how these two packages are being wired to get a result. So let's start with the package 7476, because this is a peculiar package. It's not a standard one. It's not a very user-friendly. Simply because if I'm writing it here, 74, it doesn't matter if it is LS or another version, but it is 76. The first trouble you are going to have is how to connect the pins for the supply. The package itself has 16 terminals, but unlike the standard packages, you expect the ground to be on the pin 8 and the positive voltage on the pin 16. That package, I told you already, is not user-friendly, and you have to notice that the VCC is on the pin number 5. So is the pin number 5. And the ground is on the pin number 13. Be very careful. So here was number 5, and here is 13. Okay? So that's not really user-friendly. Okay? So I'm going to make the links very soon, but what I want to say is that one here, the pin 5, this is connected to the VCC, which is plus 5 volt. Okay, so if I'm going to add here the notation, this is going to be the ground, and this is going to be the VCC. Okay, that's the first thing to notice about the package 7476. Okay, next thing to know, the package has, because it's a flip-flop, has a set and reset. And there are two sections here. I'm going to say section 1. Section 1. Let's say the section 1 starts with the pins here in the bottom, and I'm going to have here the pin 2 is a set. The pin 3 here is a reset. Reset. Okay? Where did I take them from? From the manufacturer specs. Okay? But this is the set for the section 1. That's the reset for the section 1. The J and the K, because the JK flip-flop. And by the way, 2 JK flip-flops in the package. This is why I call section 1 the first flip-flop. And here section 2 is going to be the second flip-flop. Now I'm talking about the first flip-flop. The set and reset are here. And now the J and the K. This is the J for the section 1. And the K for the section 1 is here. And the set and the reset, because on the specs they have a bubble, they have to be related to the positive 5, okay? Because I want them to not act, okay? So I put the set and the reset, then the J and the K is going to go where? To the VCC, 5 volts. So J and the K, they go to 5 volts because set and reset, I want them idle. So I write them here, 2 and 3. They are set, respectively the reset. I put them to VCC, and I keep them idle. But the J and the K, the pins 4 and 16, are the J respectively the K. I put them to the VCC because I want both active. Why do I want both active? I explained the full functioning of the 7476 in another video, and I'm going to put a link in the description. When both of them are asking for action, J and the K, then the only other input that can influence the functioning of it is going to be the clock. So when the clock signal is coming, you are going to make it a toggle switch, okay? So in order to make it a toggle switch, you need to put set and reset to the +5, J and the K both active to the +5, okay? And then what's remaining? The pin 1 is the clock for the section 1. And this one is gonna come from the push button debouncer, okay? And this is gonna be exactly what I put here, the red push button and the red LED. So this was the section 1, okay? Let's just mention it here. Pin 1 equals the clock input. And it's important to realize that for this particular package, the clock needs a falling edge, okay? And then, where can you see the result? Is on the pin 15, is the output, the normal output, number 1, because it's a section 1. And I'm gonna put here the pin 14, is the complementary output. We don't use it right now, but I put them here. Q1 is here, Q1 bar is over here, okay? And this is how we finished the section 1, okay? In order to finish the section 1, I'm gonna figure here a 1 kilo ohm resistor and an LED, LED 1, I put it here red, okay? And if you want, I can bring it here, the ground, because it's the pin 13. Section 1 is done. Section 2. Section 2 is similar here. The set and reset are going to be right here. Set number 2 and reset number 2, pins 7 and 8. And these ones, they were a bubble, so I need them to link to the +5 volt, okay? So far so good. For this one here, the J is on the pin 9, J number 2, and the K is on the pin 12, K number 2. These ones, I want both of them active. So what I'm going to do, I'm going to pick up a line to bring them here, 9 and 12. See? So they go both to the +5 volt, okay? What's remaining? I have the set and the reset. I have the J and the K. I need a clock. The clock is on the pin 6. Pin 6. It goes right here, like that. And it's coming from the PV debouncer. And I put here the green one, okay? And then, in order to collect the answer, we have here the outputs. So, do not forget, there's the clock number 2. Here is the normal output, Q2. And here is the complementary output, Q2. I don't use the 10, the complementary, only the normal. So we're going to have another resistor right here, also 1 kilo ohm. And we're going to put here another LED, like that. It has the cathode to the ground. So this is going to be the green. And these are the good links for the package 7476. Let me just figure here the pins to not forget them in the same order. 7 and 8, they are the set, respectively the reset. They go to the VCC because I want to keep idle. I don't want them to influence. Okay? Then we have the pins 9 and 12, the J respectively the K. And they are linked to VCC also, but not because I want them idle, I want both active. And then the pin number 6 is the clock clock input. Exactly like the pin 1 on the other section, it needs a falling edge over here very quickly. Okay, and finally the outputs. Pin 11 is Q2 and pin 10 is the complementary output. This being said, everything is very clear. So right now we have what? We have what's here in the top. Two toggle switches, section 1 red, section 2 green. And now let's do the other package, because the other package is 4027. Okay, forget about this one. And now we do the 4027. Okay, this is user friendly. I write it here, 4027. VCC is pin number 16. Ground is pin number 8. So here there is no trouble. I can put here ground, and I can put here pin 16, the VCC. Okay? This is user friendly not only because the power is on the pins we expect, but you're going to see that soon the two sections, section 1, here is section 2. Once you figure the section 1, you're going to be able to figure section 2 very quickly. Okay? Guess what? It has the same kind of terminals. It has a set and it has a reset. Okay? So for the set, you're going to have is this time is on the pin 9. So be careful. Of course, in the moment you realize the ground and the VCC are not on the same pin numbers as the other one, the two packages are not interchangeable. Now the set is on the pin 9 and the reset is on pin 12. Okay? So reset. Let's say number 1 and number 1 because this is the section. And I'm going to link them together. These ones, in order to remain idle because they have no bubble, this time they are related to the ground. Okay? So this is clarified. Then we have the J and the K. J is on 10, J1, and K is on 11. And these ones, I want both of them active. And because I want them active, I'm going to put them both to the VCC. Let's say J and K. Then the clock. The clock is on the pin 13. Clock number 1. So because it's on the pin 13, here I'm going to come like this from the push button red, okay, the debounced push button, okay. So we have set, reset, J and the K. Then the clock number 1 was remaining. We need outputs. So we're going to do the same as before. We connect the resistor to the output. And by the way, this is the Q1 on 15 and Q1 complementary on 14. I don't use this one, okay? And this one here, we connect an LED, L1, cathode to the ground, 1 kilo ohm resistor, job done. Now I put them here. So what do we need? We need the pins 9 and 12. These are set, respectively reset. I want to keep them idle. Keep idle. Idle. So they go to ground. And so I keep them idle. J and the K, pins 10 11, J, respectively K. I put them, just to not forget, VCC. So they go to VCC because I want both active. Then I have the clock, pin 13. Clock, and this one, unlike the 74, 76, this one needs a rising edge. What's remaining? Outputs. We have 15, 14, which is Q1, respectively Q1 complementary. And that's it. Section 2. The beauty of our section 2 is, if you already know where are located these terminals, it's going to be the same pattern in the bottom here. So I just put them in order. Q2 is here, Q2 complementary here. This is going to be the clock number 2. This is going to be the reset number 2. This is going to be the K1, J1, and set number 2. Sorry, K2, J2, and set number 2. All part of the section 2. So that one was very easy because if you can see the pattern is respected, I told you it's a very user-friendly package. So then, easiest thing to do, I'm going to pick up from here a signal to the clock. This is coming from the push button green. For the normal output, I'm going to put for the normal output here just a 1 kilo ohm resistor and an LED L2 to the ground. And then what do we do with the resets? The reset and the set, they both go to ground. Okay, exactly like here, because I want to keep them idle. J and the K, I want them active. Okay, and because I want them active, they go to the VCC. Let's put here plus VCC. And both are related over here, J and the K. Okay. And this being said, you have the wiring. So the 4027, very user-friendly. Sections 1 and 2 are organized similar way. The only thing is to figure here the pin numbers. So pins 7, respectively the 4, are here set, reset. They go to ground because I want to keep them idle. Then we have 6 and 5. They are J, respectively the K. They go to the VCC because I want both active. Then we have the clock, which this time is the pin 3. Clock, and exactly like on the other section, and unlike the 7476, it needs a rising edge. And finally, we have the two outputs, 1, respectively 2. These are the Q number 2 and the complementary. Okay, and that's it. So now you have both packages described. Maybe just to put the notation here, this was LED 1, LED 2, 1 kilo ohm resistor for each to limit the current as much as possible, and the links are done. One last view over the switches. to see how are they working, and I'm gonna put these ones on Google Drive. So to prevent the confusion, this is exactly how you wire it in order to get a toggle switch. And let's find out one last time. 74, 76, the clocks are high, and in the moment you press, they go low. So the output is toggling. If I push the red button, is the red output on the pin 15. And if I push the green, is the green LED on the pin 11. These are the two normal outputs on the 74, 76. Okay. Similarly here in the bottom, the 4027. Okay. I push the red, it goes on the output 1, pin 15. And I push the green, it goes on the output 2, the pin 1. See? So that's how you build toggle switches with two very distinctive packages. One is TTL, the other one is standard CMOS. So the confusion should be very well clarified. And I'm discussing this to prepare you for some next projects to make sure that everybody knows how to wire them. Thank you very much for today. See you next time. Bye-bye.